The Javits Center in New York recently underwent a highly celebrated retrofit, topped with what became the largest green roof in the state. It is an undeniably excellent upgrade, delivering an estimated 26% reduction in overall energy use. But look closer at that massive glass exterior. The recent work was essentially a 9-figure correction to a structural envelope drawn in the late 1970s. Some of the industry's most lauded environmental achievements are exactly this: incredibly expensive apologies for bad initial geometry. New York provides the clearest example of treating carbon. Local Law 97 places a hard cap on emissions for most buildings across this dense skyline. If an owner goes over their allowance, they are assessed a financial penalty for every extra ton of carbon dioxide equivalent they produce. A price per ton turns a physical flaw into a negotiable line item. To bring the numbers down, an owner might buy cleaner grid power or spend thousands swapping out a massive industrial chiller like this one. This is known as operational carbon, the energy a building uses year to year. Because it is highly legible, annual, and easy to negotiate, an entire certification economy has grown up around it. But paying a penalty or upgrading a mechanical system does not touch the physical shape of the building itself. We have engineered a massive blind spot by focusing almost entirely on the half of the timeline where carbon can still be bought back. The untradeable half of the equation is embodied carbon. Globally, buildings and construction generate roughly 37% of all carbon dioxide emissions, and a huge portion of that is locked in before the doors even open. Embodied carbon is spent entirely upfront at construction. It is the raw material dominance of the deep foundation, heavy steel structure, and exterior envelope. Once that frame goes up or an existing structure is demolished to make way for it, the carbon is spent. There's no annual compliance period where you can magically unpour concrete. Modern sustainability standards like LEED v5 now mandate that project teams assess this embodied material footprint, but they ask for the math at the exact wrong moment. Required quantification arrives when a digital model is highly detailed. By the time you can accurately calculate the structural load, the geometry of the building has already stopped moving. We are measuring carbon at the point of no return and mistaking late-stage accounting for actual environmental rigor. A building's carbon footprint is truly decided by its foundational geometry: the orientation to the sun, the overall massing, the window-to-wall ratio, and depth of the floor plate. These choices set the ceiling on every energy number that follows, and they are usually settled in the first few weeks of a project, often by 2 or 3 people with a single sketch. Everything added to the plan after those initial weeks is a trade, a swap to fix that first drawing. For example, installing heavy triple glazing is spending embodied carbon to correct a bad glazing ratio, or taking rooftop solar panels, which spend weight and manufacturing emissions, to artificially offset a floor plate drawn too deep for natural daylight. A self-daylighting plan compounds benefits, paying off every year with no invoice. But this compounding cost curve on the right represents continuous penalties required to fight a bad layout. What we praise as advanced technology is often just a tax for bad geometry. The structural failure sits in the industry's tooling. Current carbon assessment instruments are highly precise, but they are painfully slow and land months too late to influence the core shape. What the concept phase actually needs is the exact opposite: coarse, lightning-fast comparisons across dozens of massings during week 2. This speed matters because week 2 is the last moment the answer is still completely free to change. A fortnight of genuine, data-backed divergence before a building's massing freezes is the highest return investment available on any project. Because the irreversible truth of architecture is this: once ground is broken, no amount of money or mechanical technology can buy back a bad orientation. This is exactly why we built Depix. It is a tool designed specifically for those crucial early weeks before anything is physically fixed. Initial design decisions are as cheap as a sketch, but they are brutal once they are tooled into reality. You must see every angle before you build.